A very good morning. This is Dr. Sajja Suneel from Data Science Department. Today we are going to discuss about principles of IoT, particularly about the differences between SDN and NFV, Software Defined Network and Network Function Virtualization. We are going to discuss about the differences in various scopes. Let enter into the quick view what exactly SDN was and what exactly NFV was and what are the major differences by comparing with various scenarios, as well as we are going to discuss about an introduction towards the basics of network management. And this network management will be done and taken care by using three different things: net configuration, young network, as well as SMTP operators. These are the three different kinds of things which we are going to discuss. The basics are going to be discussed in today's class. Today's class we are majorly focusing on the differences between SDN and NFV. What exactly SDN was and what exactly NFV was, and what are the different scenarios in by comparing with multiple aspects in these two different aspects. Let enter into the discussion. As I told you from the past classes also, IoT, the principles of IoT course, which is going to provide us a basic comprehensive understanding about fundamental concepts such as the different kinds of applications and different kinds of principles which are related to Internet of Things. And here the students are going to explore different kinds of principles which are designed in IoT, and they are knowing about the underlying architecture, networking, security, as well as different kinds of emerging trends which are involved in this Internet of Things. As day to day, IoT is becoming the biggest sector. Why? Because man's needs are increasing a lot. The same similar way, everything is automized, and by using this Internet of Things, we are implementing in every kind of systems which we are regularly utilizing, like home automation system, weather conditioning system, weather monitoring system, smart city system. Like this, multiple kinds of people are using IoT systems today. And our main intention was, what are the different things which are underlying in this particular things? What are the underlying networks? What are the underlying principles? What are the different kinds of designs which are evolved in this particular IoT? We are going to see. And in this particular thing, the topic comes under the second module, which is Internet of Things, Networks and Management. The particular topic which we are discussing today comes under network and also comes under management. We are going to discuss about the basic things of network managing sector. And today we are majorly focusing on this particular IoT network, which is SDN, Software Defined Network, and Network Function Virtualization. What exactly SDN was, what exactly NFV was, and what was the differences between these two by comparing multiple factors. Those are going to be coming in our coming slides. Have a look how exactly the things are. See, from this particular module, students are going to be able, what they are going to get from this current discussion, as well as from this current IoT networks and management module, what we are aiming for, what are the objectives, especially we ensure that a reliable and scalable connectivity has to be established in IoT system by based on this IoT network. And also we ensure the secured communication and provide an efficient data management. Here we are able to optimize a device performance and also simplifying the network management from this particular module. What finally, after discussing about this particular module, what student is able to get and what he is able to get, the things are such as he is going to know about how to improve the operational efficiency by using this network management as well as different kinds of networks, and how to enhance the security levels in this network and management, how to improve the scalability, how to improve the growth he is able to know, and also he is able to know how to reduce the downtime and how to improve the customer performance in a particular IoT system. These are the things which students are able to know from this particular IoT networks and IoT network management. and what exactly. And now we will enter into our major topic, which is differences between software defined network and network function virtualization. And coming to the first topic, which is SDN, which is software defined network. We have to know, before discussing about the differences, what SDN was and what NFV was. SDN is a software defined network, which is a new networking paradigm, which is going to separate the network controls and data planes. What network controls are and what data planes are. In every kind of networking, we are, by using this software defined network, we are going to design a new network paradigm, which is going to specifically separating for the data planes as well as the network control. In network only, the data is going to be transferred by using a particular IP version 4 or IP version 6, some kind of communication protocols. And here, this SDN is a traditional networking architecture, which is tightly coupled what exactly it is going to tightly couple the relationships between data and the control planes. Why the relationship has to be proper between the data and the control planes? Because data is going to be transferred through these particular planes. For that particular purpose only, a particular coupled relation has to be maintained. Here in this network device, the routers, the switches, whatever we are using, those are the responsible devices for forwarding the information in form of packets, and also how that particular data has to be transferred with this particular network and how it should be operated. All these things has to be taken care by this particular software defined network. And in this software defined network, the control plane is going to be decoupled. Why it is decoupling? Why it is decoupling? Because as I told you previously, it was a paradigm which is going to separate the data as well as the control planes. In the same similar way, here it is going to be decoupled from the data plane, which is implemented in the software by allowing the centralized network control. What centralized network control? Centralized network control is the thing which is presented in software defined network to have a control over the network by observing from a centralized area. That is what centralized network control was. And here the control plane is also capable of this particular network controller, which is responsible for making decisions how the data has to be transferred, in which path the data has to be transferred, how the congestion has to be avoided through the network. All things should be taken care. And here we are also able how the traffic should be forwarded and how it should be parallelly biased over the network. And here the data planes, on the other hand, which are responsible for forwarding these traffic based decisions through this control plane. This is how this particular SDN is going to function. And particularly in this particular software defined network, the devices, as I told you, switches, routers are the responsible devices, IoT devices, which are going to take care of transmission of data from sender to destination, from source to destination, by using a specific path with the help of the centralized network controller. Here also the same thing is which is going to be discussed in this particular point. The network devices such as switches, we can call routers also, these are the typically simple as well as the low cost devices which are going to transfer the data from source to destination. For suppose I am the source, you are the destination. I want to transfer a data to my students. For that purpose, I have using a software defined network. By using a IoT device, I have initialized, which is in my home device, there was a switch or there was a router. These are the responsible devices which should transfer the data from source to destination purpose. And whatever the instruction which is received by me from source, the instruction has to be carried out to the destination with the help of the network controller. What controllers are? We are talking about software defined network. We are talking about network function virtualization. We are talking about centralized network controllers. So what these controllers are? Controllers are nothing but the Centralized network controller means in a network, any kind of network, there is a centralized admin who is going to control which type of data has to be transferred and what type of data and control planes has to be segregated. As I told you, this particular software defined network is an architecture which is going to separate the data and the control planes. For that particular purpose, we need a controllers which is going to control the which is going to have some kind of information how the data has been transferred from source to destination. Whether is there any kind of delays which are happened at the time of transferring of data, the entire information can be taken care by these controllers only. Controllers are the communicators which are used by the switches by using a standard protocol such as OpenFlow, which was discussed in our previous class. In OpenFlow diagram, we have clearly shown all the things how the controllers are going to function. Here, this particular OpenFlow, which is going to allow the controller for programming the switches which are going to forward in a particular way from source to destination. In a particular way only the data has to be transferred. These are the things which are going to be taken care in this SDN architecture. And coming to the next one, which is network function virtualization, which is NFVs. This is an approach which is used in this network architecture. There we are separating the data and the planes, control planes. Whereas here in this particular architecture, we are replacing the dedicated network hardware devices with software-based virtual network functions, VNFs, software-based virtual network functions, which are going to run on particular standard servers, particular storage devices, and particular switches on specific standard switches only I will use. Standard servers only I will use. Standard storages only I will use. Why? Because it is a functional virtualization which is going to provide. We are going to replace the dedicated network hardware devices by using this SBVNFs, which are software-based virtual network functions. These are the things which are going to be replaced by our network hardware devices. In this networking, specifically, there is a hardware device such as routers, and there are some firewalls, and there are some load balancers. What these routers, firewalls, load balancers are going to do? These are used for performing specific network functions such as router are the things which is going to set the path where exactly the data has to be transferred. Router, as in the name, it is clearly specifying the router from which route it has to be transferred the data from source to destination by specifying shortest path route or longest path route. Depends on the controller only. The router is going to tell you in which way the data has to be forwarded. And coming to the firewall. Firewall is the thing which is going to provide security for the data which is transferring through the network. And load balancers are the things. These load balancers are going to balance the load. Why? Because on CPU or storage or servers, there is a lot of load. Why? Because parallelly in the network, there are n number of people who are working out, and n number of people. For everyone, the data has to be browsed. For that specific purpose, we are using the load balancers. Load balancers are the thing which are going to balance the load. Specifically, for suppose I am sending a message to one of my friend who is a destinated person. For in the same way, I am using Airtel network. In Airtel network, there are n number of people who are utilizing that service. In this, Airtel service provider is the one who is maintaining the load balancer. And due to that balancer only, I am capable to reach out a specific person, and I am capable to transfer a specific data with the help of this load balancer. These are the three kind of hardware devices such as router, firewalls, and this load balancer, which are used to perform specific network functions. And have a look what exactly we are going to do with this particular network function virtualizes. This particular network function virtualize, here we are performing a function which is going to be virtualized, and it can be run by using a software on commodity hardware, which leads to greater flexibility, greater scalability, and cost effectiveness. With this particular network function virtualization, we are going to get some features such as flexibility, scalability, and cost effectiveness. Whenever we are using this network function virtualization, we are going to enable the network operators very quickly. why we are able to do these things very quickly? Because here by using this network function virtualization, we can do the things quickly, easily, and also we can deploy the things by using the scalable network functions which are needed for us for establishing physical hardware installation or for maintenance purpose. These are going to be very helpful if we use this network function virtualization. And also it is very oftenly used in congestion. What congestion was? First, suppose there is a source and there is a destination, and there is another source and there is another destination whose where like this, and treat n number of sources and number of destinations. If this source and destination and this source and destination are selected to the same path and they are trying to transfer the data to the same destination, in the network there is a congestion which is going to happen. Let me tell you in a real-time example. There is a specific door in your respective classroom. Whichever you and your friend are trying to exit at once, or else you and your friend is trying to enter and you are trying to exit. Is it possible through a single door where it is having less space? No, right? That is where the congestion will occur. At that particular point of time, the controller is the one which is giving instruction to you or else to your friend to take a step backward, or you need to wait for some particular fraction of seconds. Then this particular data is going to be transferred to the destination. Immediately after that particular second, you are going to be addressed and your issue is going to be resolved. Like this, the congestion is going to be avoided with the help of this particular software defined network. By using this particular approach in this network function virtualization, as I told you, SDN is the thing which is going to separate the control plane and the data plane which is presented in the network. As I told you, by using the SDN architecture, I am separating the data as well as the control plane, which is specifically used for allowing a centralized network management or else orchestration. And here, by togetherly we are combining. If you observe the scenario in this network function architecture, we are replacing to avoid the congestion by using this SDN, right? By using this SDN. Togetherly, by using network function virtualization and SDN network, we are enabling the network operators which is going to be used for building more agile and more effective networks which are going to adapt for changing the businesses and for changing the user requirements. Day to day, there are n number of evolutions, n number of advancements which are happening in the industries or else in the human requirements. For to equip these kind of things in our IoT systems, we have to use both together and to give the best services and to give the best requirements which are going to be fulfilled by our IoT system with the help of this NFVs and SDNs. SDNs are the software defined networks, NFVs are the network function virtualizations. Now we'll have a look how the differences between this SDN and NFVs are. SDNs, software defined networks, I already told you. NFVs, network function virtualization. These are the technologies which are aiming to improve the network agility. The first factor is these are the two technologies which is aiming for improving the network agility, which means excuse me, in network there is a factor where there's some kind of congestions or else some kind of network dropping to the internet connectivity. Those factors can be avoided for improving the network agility, network flexibility, and also for improving the efficiency in the network. We'll use these two technologies together. Here we are by using these two technologies, we are avoiding a situation like someone may overlap in two different concepts at that particular point of time. We are specifying the differences between these two specifically. By using these scenarios, whenever it is required, we are using the SDN network. Whenever we are using SDN network, we are separating the data and the plane control and the control planes. And whenever we are using NFVs, we are replacing the hardware with the new network things, networking concepts such as new routers, as I told you in the previous things. And have a look what are the differences by comparing with multiple factors such as scope, functionality, like this multiple things are there which are going to be discussed in the coming slides. Have a look what SDN and what NFV, how the scope of these particular factors are. As I told you, SDN is primarily focused on controlling the management of network. That is what the traffic flows from which source to which destination the data has to be transferred, whether it is particular going in a proper direction or not. It is going to control and manages the network flows. Whereas excuse me, whereas in NFV it is purely focusing on the virtualized and network management on the network functions. Coming to functionality, here in SDN we are maintaining a separate control plane. As I told you, SDN is the architecture which is going to separate the data and these control planes. Control planes are nothing but which is determining where exactly the traffic is routed, and also data planes are there which is going to handle actual transmission of data. As I told you, these are the two things which are going to take care: data plane and control plane. Control plane are the things where exactly the traffic is routed, whereas data plane which is going to handle actual transmission of that particular data. By using this particular scenario, it is going to allows you for more flexible and more programmable network. This is what SDN will do at the time of functionality, whereas in NFVs are the things which is a virtualized network such as routing, switching, firewalling, load balancing, and which is also allowing different kinds of functions which are deployed and which are used for managing the software virtual network functions. As I told you, there are some particular things which are going to be replaced with this particular network function virtualized architecture, where it is removing the existing hardware devices and replacing with the software defined hardware devices, such as with the help of routers, with the help of switching, with the help of firewalls, with the help of load balancing, and also allowing these particular functions for deploying and managing the software based virtual network functions. This is how the functionality between SDN and NFV. How the deployment will be in these two things. SDN deployment, this was the factor. SDN, which requires a specialized network hardware such as switches and routers. Why this hardware is required? To support our overflow, open flow, which is other SDN protocol. Whereas in NFV deployment, it is going to use a particular standard server such as x86 server, and as well as it uses a special storage purpose, and it will use a standard switches, standard storage, standard switches, and standard servers. These are the things which are required for deployment of this NFVs. Whereas how the management and orchestration will be done in software defined network. In software defined network, it is going to do in a centralized controller format to orchestrate the network traffic flows. Whereas in FSCs, it is typically focusing on the deployment of the management of VNFs, virtual network functions, which is defined by software based. These are the two different scenarios, two different differences between SDN and NFVs. What are the standards in SDN? What are the standards in NFV? In SDN, we are using Open Networking Foundation. This was the standard which is used for controlling the open flow control protocol. Whereas in NFV, which is Network Function Virtualization, we are using European Telecommunication Standard Institute and also industry specific group which is related to network function virtualization. These are the standards which are used in both SDN and NFV. In SDN, we are using ONF, which is Open Network Foundation for and Open Flow Protocol. These are the two things: Open Networking Foundation and Open Flow Protocol. Whereas in NFVs, we are using ETSI, European Telecommunication Standard Institute, and ISG, which is industry specific group, which is a specification group. Here, the both technologies, if you understand properly, the both technologies are based on open standards only. And here there is a slight differences which has to be discussed, like what kind of standard it was using, what kind of protocol it was using. That was a small difference in between these two networks such as SDN and NFV. And coming to the next scenario, network architecture, and where this network architecture is going to be helpful how this particular aspect is different from SDN and NFV. In SDN, it was a typically designed network architecture. Why? Because it is used to create a centralized SDN architecture, which is more programmable and easier to manage. Whereas in NFV, it is focused on virtualized network function for creating a flexible and scalable network architecture. If you observe here in SDN, it is purely designed for more programmable and SDN architecture. And whereas NFV, here it is designed for flexible and scalable network architecture. And coming to the next thing, which is network abstraction. This was the difference between, and here in SDN, this particular network abstraction, what abstraction was, which is going to abstract things about the data which is going to transfer. And here in SDN, which is going to abstract the network infrastructure from the control plane or data plane, which is going to allow your administrator for defining the network policies and what are the different configurations which has to be used in the underlying hardware. Whereas in NFV, how the network abstraction will be done, this here by using NFV, here we are allowing what the things has to be deployed, what the things has to be managed independently by using the physical infrastructure. This is how the network abstraction will be done here. Whereas in service delivery module, how these two are different and how these two will behave. In service delivery, SDN is going to use and which is going to enable a new service delivery models such as network slicing, which is going to allow our network resources to be allocated dynamically based on specific applications or servers. Whereas in NFV, it is also enabling some kind of delivery models, but here it is allowing basically a network functions which are to be deployed and scaled up and down based on demand. Based on demand only it is performing, but here based on the need of specific application and services it is performing. That is what the difference between SDN and NFVs in service model. Coming to vendor ecosystem, SDN has a larger and more nature vendor system, whereas NFV is a relatively new technology. Vendor ecosystem is still evolving here, whereas SDN is a old technology. Vendor ecosystem is fully established with NFV with a wide range of products and multiple solutions here by using the network energy, as well as startups also using this particular technology. Overall, I want to conclude that by considering the above all discussed aspects between this SDN and NFVs, these two networks are really important for us for controlling and for managing the network, software defined network and network function virtualization as going to be used in our IoT systems. Overall, there is some overlaps I can conclude here between this particular SDN and NFV, but the technologies have different goals and different approaches. SDN is primarily focused on traffic flow management and control, where NFV is fully focusing on virtual network functions to enable flexible and efficient architecture. See here once. SDN is primarily focused on traffic flow management and control. NFV is particularly focused on virtual network function and more efficient network architectures. These are the differences, major differences between this and SDN and NFV. And these two technologies can be used together for creating highly dynamic programmable networks which can adapt the changing of the business and user requirements. This is how I can conclude this SDN and NFV, and both can be used. Once again, have a look. SDN is primarily focused on traffic flow management and traffic control, whereas NFV is focused on virtualized network functions, which are very used for enabling more flexible and efficient network architectures. If we use both SDN and NFV together, then it is going to create highly dynamical and programmable networks which can adapt for changing the business requirements and also for changing the user requirements. These two can be used together. This is how I can conclude the differences between this SDN and NFVs. And also there is a complementary technologies which are going to be used for flexibility scalability, and efficiency of the network architectures. We are going to aim, and our common goal is to enabling more agile and adaptive networks in the business point of view or else user point of view. Now we'll start discussing about the basics of IoT system management. What exactly IoT system management? Every IoT system has to be managed by the user or to be managed by the administrator, where we require some things in the management area, such as need for IoT system management. What was the exact need? Why a system has to be managed? The first one is the devices should be automatically configured. And what automatically configuration means? Automatic configuration means every device is configured by basing on the in what we call in installation time. There will be some advanced technology which is installed in it. So if we send an update to that particular device, it should be updated as per the technology trends. Then only the device will give you the best performance. For that particular purpose, we require an automatic configuration. And also monitoring operational and statistical data. A continuous monitoring of operational as well as the statistical data is required for us, and we need to improve the reliability of that particular device. Why? Because if there is reliability, then only we can say that particular device is producing the accurate data from its source. And also we improve the system-wide configurations, which is related to storage, which is related to hardware compatibility or software compatibility. We need to improve the system-wide configurations. And also multiple systems are involved in IoT systems, so we need to check the multiple system configuration, whether it is suitable to this particular device or not. And also we have to retrieve and reuse multiple configurations. These are the 6 different kinds of needs which are very helpful for this particular IoT system management, such as automatic configuration, monitoring operational and statistical data, improving reliability, system-wide configurations, multiple system configurations, and retrieving and reusing the configurations. These are the things which are very much required to us. And as I told you, I will start discussing about this particular concept in detail in the coming class. But I just want to give some basics why these things has to be managed in Internet of Things by using network configuration and SNMP and netoperator. These are the 4 different things. In IoT, we brings a particular connected devices for managing a part. It becomes very crucial. What are the basic breakdown of some particular protocols and tools which are involved in IoT system management? The first one is SMP, Simple Network Management Protocol. What exactly it was? It was an industry standard protocol which is used for network device management. How it will work? Uses a manager agent module. The manager is NMS, Network Management Station, who is going to send request to agent who is running on the devices, MIBs, management information, or changing configurations. What are the pros and cons of using this NMP? It is widely adopted, simple to set up, and cons: limited data modeling capabilities and secure concerns in older versions. So the best example is your mail. It was a limited data modeling capability, and it is widely adopted by multiple people, right? For that purpose, simple network management protocol, the best example is your mail system. And coming to the next one, net configuration and ANG. What these are? A powerful duo for managing the configurations and network devices. Netconf, what netconf and what ANG was? Netconf, a protocol which is going to define how to communicate between the devices and how to configure that particular management by using a specific SSH transport for communication. Coming to ANG, ANG was the data model, which is the ANG was a data model language which is used with network configuration, which is defining for the structure of the configuration of the system. And how this particular things are working together. Network configuration was the thing which is provided communication framework, whereas ANG was the thing what and how the data has to be exchanged. It is providing the communication framework. For suppose it will give you have to transfer the data from A to B. This was the communication framework which is given. ANG is the thing what and how it has to be transferred. This will be taken care by YANG, and this will be taken care by net config. It only provides you what has to be done, and YANG is going to take care what has to be done and how it has to be done. What are the pros and what are the cons? Pros are like flexibility, and it is more secure, and it is also allows the complexity to data. And the cons are steeper learning curve, which is compared with SNMP. These are the things when you compared with network conf and YANG protocols. And coming to net op, what net op was? It is an open source software which is suitable for network management, and here it provides a specific tool. I am telling about how it is going to function. Network net op, it is going to provide you a tool for configuration the management protocol, and also for automation of using network configuration and SNMP. What are the benefits which we are getting by using this net op? We are offering with a comprehensive platform for managing the diverse network devices, including the IoT devices support such as network configure and SNMP. In summary, this is a quick brief about this network conf, YANG, net op, and SNMP. SNMP, which is offering a basic and widely used approach in smaller, simple configuration devices, whereas network conf and YANG provides a most powerful and flexible solutions for complexly configurations and data modeling in the modern IoT systems. NetOP, which is going to serve you a practical toolkit and for leveraging the protocols and managing the IoT sector. If you observe, it is very simple to use, and here it is providing a powerful and flexible solutions for configuring, and it is providing a toolkit for leveraging your IoT infrastructure. You need to choose the right approach depending on some factors. What those factors are? What exactly the complexity of your IoT devices which you are using, and what the configuration needs are. But based on this particular factor, you need to choose either SNMP or network configuration or YANG or network OP. And also you need to verify your desired level of automation and security. But based on this, we need to choose the above three. And also you need to verify what exactly your existing network management infrastructure was, whether this infrastructure was suitable for SNMP, or this infrastructure was suitable for network YANG, or this infrastructure was suitable for this net op. By based on these particular factors, you need to choose which particular system management is more helpful to us. These are the 4 things which we will discuss in detail along with the diagram in the coming class. That's it for today. Signing off, yours Suneel sir. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.